Solve problems on game theory by using following rules. Rule 1. Look for a pure strategy saddle point. Rule 2. Reduce game by dominance. We will read the first question. In a certain game, player A has three possible choices L, M and N, while player B has two possible choices P and Q. Payments are to be made according to the choices made. What are the best strategies for player A and B in this game? What is the value of game for A and B?
We will solve this question by using rule 1 of the game theory. Look for pure strategy, that is saddle point. Now if we observe this question, there are two players available, player A and player B. There are three choices to player A, choices are L, M, N. And in the same way, there are two choices available to player B and choices are P and Q. Now in the question, possible combination of the choices with payments is given. So here is the table that is mentioned in the question. Now if we observe, in some combination A will get some amount and in some combinations B will get some amount. Now here we will consider player A will be first player and player B will be second player. So whenever the player A gets some amount or some money from player B, then we will consider that amount that is positive. And when B will get some amount from player A, then that will be the loss to player A. So whenever B will get some amount, then we will consider that amount will be negative. Now we will construct here the payoff matrix. So this matrix we have to construct for the payoff as mentioned in this table. So here this payment is mentioned for the possible combinations of the choices for player A as well as player B. So for player A, we will mention here the choices in the form of rows. So here will be the first choice L, M and N. So for these three choices, we will construct the three rows. And for player B, because this is the second player, we will construct the two columns for the two choices. That is the column for choices P as well as Q. Now here we have to mention the amount. Now if we observe the combination of choices L and P. So in this matrix, here is L and here is P. So we have to mention here this amount. So A pays B rupees 3. That means there is loss to A for rupees 3. So we have to mention here minus 3. Then L and Q. So here is L and here is Q. So we have to mention here B pays A rupees 3. So here A will get some amount. So we will consider here the positive number. Then M and P. Here A pays B rupees 2. So here B will get some amount. So for M and P combination we will mention here minus 2. Then M and Q. B pays A rupees 4. So here A will get some amount. So we will mention here positive. For N and P, B pays A rupees 2. So here also A will get some amount. So we will mention here positive. N and Q. B pays A rupees 3. So here also we will mention the positive number. Now again we have to apply one rule. So here in this game theory, first player is the player A and player A should always try to maximize the payment, while second player, that is player B, should always try to minimize the loss. So this maximize payment amongst the minimum payment. That means from each row we have to select the minimum value. And here minimize loss amongst maximum loss. So this column indicates the loss. So from these values, from the first column and second column, we have to choose the maximum value. Or we have to select the maximum value. So now we will move for the first player A. So for the player A, we have to select the minimum values and those values will be payment. So what is the minimum value? So in between -3 and 3. So minimum is -3. Then -2 and 4. Minimum is -2. And 2 and 3. So here minimum is 2. Now what is the meaning of this? So suppose player A will select the strategy L. Then for this strategy L, here he will get the amount in between these two, that is loss or gain. So he will lose 3 rupees or he will get 3 rupees. Now he will lose 3 rupees or he will get 3 rupees. That will depend on the strategy or choice selected by player Q. So now he has to select this minimum number. Now in the same way, if he choose this strategy M, then in between this, so he will lose rupees 2 or he will get rupees 4. Now it will depend on what strategy or choice is selected by the player Q. So that is not known. So he have to choose the minimum number. So minimum number, that is -2. Now if he select the strategy N, then he will get rupees 2 or rupees 3. So minimum number is 2. Now we have to select the maximum amount. So in between this minimum of each row, maximum value is 2. So I will make here the bracket. So here we can say that this value is maximin, that is maximum amount from the selected minimum values. So I will write here, this will be maximin. Now we will move for the player B. So we have to select the maximum values from the column. So for the first column, what is the maximum loss for player B? So in between this -3, -2 and 2, maximum loss is this 2. Now we will move to the second column. So for the second column, maximum loss is 4. Now we have to select the minimum value. So what is the minimum loss? So minimum loss in between 2 and 4 is 2. So we have selected the minimum amount from the maximum value. So we will say that this is the minimax value. Now if we observe for this question, here maximum value is equal to minimax value. And so we can say that the strategy is optimal strategy. So what is the best strategy? So here best strategy for the player B will be, he should choose this strategy or choice P, and for player A he should choose this strategy A. So these are the best strategy available to player A as well as player B. Now this game is having saddle point, or we can say equilibrium point, or this is the stable game. So what is the saddle point? So for saddle point we have to first mention the row. So here this is the third row. And then we have to mention the column. So here is the first column. So saddle point is 3, 1. Then we will move to the next. So we will say the game is fair when maximum value is equal to minimax value is equal to 0. But in this question, this maximum value and minimax value is not equal to 0. So whenever this condition is getting satisfied, that is maximum is equal to minimax is not equal to 0, then we can say that this game is strictly determinable. And what is the game value? So game value is this, that is maximum value and minimax value. So we can say game value is +2. So we will say here the game value is +2. Now this strategy that is getting adopted by player A and player B, that is the combination of this N and P, is known as the optimal strategy. And what is the pure strategy? pure strategy is the decision rule to always select particular course of action. So here particular course of action is getting selected, that is the combination of N and P. In this, for this question, and this combination of course of action is the optimal strategy, and that is getting selected amongst the all pure strategies. Now if we observe, this question is for two person, we will also say this is the zero sum game. Now why this is the zero sum game? So zero sum game, that means gain of player that win is equal to loss of player that lose. So whenever the player A will get amount 2, then there is the same loss, that is amount 2, that is rupees 2. So here gain of player that win is equal to loss of player, that means here this is the game under zero sum game, and saddle point is also there. So we can mention this question as a two person zero sum game with saddle point.
Second question. Reduce the following game by dominance property and solve it. This question was asked G.N.D.U become April 2011, P.U become April 2011, April 2006.
For this question, there are two players, player A as well as player B. For player A, there are 4 strategies or alternatives available, and for player B, there are 5 strategies or alternatives available. Now for this question, we have to apply the dominance property and we have to reduce the game. Now let us understand two important rules to apply this dominance property. So first rule is every value in dominated row must be less than or equal to remaining or at least one dominating row or rows. Now here if we observe, there are two important words, dominated row and dominating row or rows. Now here we have to delete or we have to remove dominated row. Now for this dominated row, every value in this dominated row must be less than or equal to remaining rows or remaining at least one of the row. Now if we observe this question, here the different values are given. Now we have to find out the row in such a way that means we have to always seek for dominated row, for which the values should be less than or equal to the remaining rows. So if we observe, here is 2. So 2 is less than 3 and 6. Then here is 0. 0 is less than 4 and 5. Here is 6. So 6 is less than 7. So here we should not consider this row second, because here 6 is less than 7. Then here is 3. So 3 is less than 6 and here is 1. 1 is less than 5. That means we can say that this 4 is dominated row. And which is dominating row? So from other 3 we have to select the dominating row, or there may be number of rows, that means there may be a number of 3 number of rows, but here in this case only one row is dominating. So this is the dominating row. Now we have to always remove dominated row. So we will remove this and we will write the remaining. So we will remove this 4th row. So remaining will be 1, 2, 3. And here 1, 2, 3, 4, 5. That will be columns. Now I will repeat the numbers. That is 1, 3, 2, 7, 4, 3, 4, 1, 5, 6, 6, 5, 7, 6, 5. So this is the second step. So we have to remove this dominated row. Now again we will move to the next rule. So next rule, for column, every value in dominated column must be greater than or equal to remaining columns or at least one dominating column. So here we have to again select the columns. Now For the dominated column, we have to search for the greater values from the remaining columns. Now, if we observe for this question, here 7 and 4. So, if I observe here 1, 3, 2, 7, 4. So, these 7 and 4 are the largest numbers. Now, we will move for the remaining two rows. So, here is 5. So, 5 is greater than 4. So, here 7 is greater than 3, then 5 is greater than 4. Then again if we observe 6 is greater than 5. So I will say that this is the dominated column because all the values are greater than this row, column 2. So this will be the dominating column. So we can remove this fourth column because this fourth column is dominated by second column because all the values are greater, or we can say equal, that is also possible. Now here we will again search for the second column. Here are values 4, 6, 5. Now this 4 is greater than 1 and 3. Then 1, 3 and 2. Then 6 is greater than 3, 4, 1. And again 5 is greater, so 5 is not greater than 6 and 7, but 5 is equal to 5. So again we can say that this column 5 is the dominated column by column 2. So again this fifth column is also dominated because every value is greater than or equal to this second column. So this second condition is satisfied. So these two columns that we have to remove. So remaining values I will repeat. So we have to give the numbers of column because 4 and 5 are removed. So remaining is 1, 2, 3 and here rows 1, 2 and 3. Now I will write the number 1, 3, 2, then 3, 4, 1 and then 6, 5, 7. Now again we will find out the dominating rows. So if we observe, we have to select dominated row which is having less than or equal to other value, less than or equal values than other rows. Now if we observe here this row 1, here is number 1 which is less than 3 and 6. 3 is less than 4 and 5 and 2 is less than 7 because here is the number. So this will be dominated row. Dominated row, and this is the dominating row because all the values are less than this row. So here this is the dominating row. Now again we will compare for the second row. So 3 is less than 6, 4 is less than 5 and 1 is less than 7. So this is also dominated row because all the values are less than this remaining row. So here these two are dominated by this third row, and third row is the dominating row. So we have to delete these two rows and only one row is available. So I will mention the number. So here for player A, third row is available and here player B, 3 columns are available. Now I will mention number 6, 5 and 7. Now for player A only one strategy is available. So he will play with strategy third. But for player B there are 3 strategies are available. And we know that player B should seek to minimize the losses. So what is the minimum value? Minimum value is 5. So player B should take this strategy second. So what is the strategy for A? Strategy for A is third strategy and strategy for B is second strategy. And what is the game value? Game value is 5. Now we will move to the second case where for player A 3 number of strategies are given and for player B three number of strategies or alternatives are given, and the question is that we have to reduce this game by using dominance property. Now we will first find out the dominated row. That means every value in that row must be less than or equal to the values from the remaining rows. Now if we observe here, 0 is less than 6 as well as 2. But the second element in the second row that is greater than the other elements. Now we will move to the next. That means this row number 2 will not be dominated row. Now we will move to the next. So next row will be 3, but number 2 is greater than the 0. So here this row number 3 will not be dominated row. So in this question there is no any dominated row. Now we will find out the dominated column. Now every value in dominated column must be greater than or equal to other values. So here we have to find out the greatest value, that is 6. So 6 is greater than 1 and 3. But the second element 0 is less than 9 and 7. So we will this column number 1 will not be dominated column. Now here if we observe number 1, and in between 1 and 3, 3 is greater. So 3 is greater than 1, but 7 is less than 9. So again there is no any dominated column. So how to reduce this game by using dominance? So we will use here the average. So we will take the average for the strategy 1 and 2 available to A. So I will make here the average number. So how to find out the average in between the strategy 1 and 2? So 6 plus 0 by 2. 6 plus 0 divided by 2, comma 1 plus 9 divided by 2, comma, and 3 plus 7 divided by 2. So what is the answer? 6 divided by 2, that is 3. Then 10 divided by 2, 5, and 7 plus 3, 10 divided by 2, 5. Now we will compare. So because this is the average of 1 and 2, so we will compare these numbers with row number 3. So if we observe, each element from this row number 3 is less than this average, that is 2 is less than 3, 3 is less than 5, and 4 is less than 5. So we can say that this row is the dominated row. Dominated row by this average of these two dominating rows, that is the average of these two dominating rows. So this row we can delete. So I will write here the remaining numbers. So here for A there are only 2 strategies, and for B there are 3 strategies. Now we will put the numbers 6, 1, 3 and 0, 9, 7. So in this way we can reduce the matrix by using the dominance property by taking average.